Good morning, everyone. My name is Sean Woody. I'm Chief of the Track Research Division at the Federal Railroad Administration. I am pleased and excited to be able to give you an overview of FRA's research program. I will be covering a lot of material, and I apologize in advance for going fairly quickly and keeping it at a 50,000-foot view, but that is probably to your advantage because if I didn't have a time limit, I could probably talk for hours about all these different topics. I'd like to start my talk by commenting on the technology paradox that is the railroad industry. I think if you ask most members of the general public, they would characterize the industry as very low tech. In fact, there's probably more than a few people that would be quite surprised to learn that the industry doesn't use steam locomotives anymore. That view that the industry is low tech is valid in some ways. Many systems that are still in widespread use date back to the late 1800s. Those include air brake systems, track circuits, couplers between the freight cars, and the tapered wheel sets used to steer the freight car trucks around the curves. They're all simple and elegant solutions to very practical problems. However, I don't think the public realizes the extent that the industry has embraced some cutting-edge technologies. Some examples of those technologies are positive train control, which prevents the trains from colliding, machine vision, which is now utilized throughout the industry, machine learning and artificial intelligence, whose applications have absolutely exploded in the industry, sophisticated simulation software, and alternative fuel and locomotives and battery locomotives. I'd like to share a quick story about this technology paradox. About 12 years ago, I was managing the track geometry measurement cars for a railroad. We had just completed an upgrade of the instrumentation systems on those consists, which each one had a 1920s vintage passenger car. Somehow Trains Magazine, which is a train enthusiast magazine if you're not familiar with it, found out about the project and asked if they could write an article. The writer that came and rode the car made a very interesting observation. It turned out that he wrote for the magazine as a hobby. His day job was actually in the public relations department at the Indianapolis 500 Speedway. He said that the technology that we were using on the rail cars was every bit the equal of the technology that he saw in the IndyCar and Formula One series at the Speedway. And I think a lot of people would really be surprised at that favorable comparison. On that note, I'd like to introduce the Office of Research, Development, and Technology, or RDNT. We're a sub-office in the Office of Railroad Policy and Development at the Federal Railroad Administration. We have an arm's length relationship with the Office of Railroad Safety, which is FRA's regulatory and enforcement arm. We do perform targeted research and provide technical expertise to the Office of Railroad Safety, but the fact that we're not writing tickets allows us to collaborate with the industry on research. I'd like to start with a quick comment about RDNT's mission statement. In my opinion, the most important word in this whole statement is the word solutions. I think we can all think of research project that developed a technology solution in search of a problem. And sometimes that's great. It leads to an unexpected breakthrough application in another area. Think of all the medicines that work for a completely different illness than they were originally intended for. However, we need to have a strategic plan that clearly defines the industry's problems and make sure that we're targeting research towards solving those problems. I will note here that we do not fund basic research, which we consider to be at very low technology readiness levels. And speaking of strategic plans, you can access RDNT's current strategic plan on the FRA e-library site, and there's a link to that in the bottom bullet. RDNT's strategic plan aligns with the Department of Transportation's 4 strategic goals. which are safety, infrastructure, innovation, and accountability. I think those first three goals are self-explanatory. Accountability means that we're trying to procure the most impactful research that we can while making the best use of the taxpayers' dollars. DOT is also currently prioritizing research related to climate change, economic opportunity and recovery, jobs, and equity. Now to talk about the structure of the office. Dr. Miriam Aliyar-Wirik is the director of RDNT and oversees the 4 research division. Each of the divisions has its own chief, and the 4 chiefs oversee a total of 22 program managers that initiate or select research and conduct the day-to-day management of those research projects. Next, I'll give a brief overview of each of the divisions. I'll begin with my division first. The track division is really responsible for everything from the top of the rail down, although we do use computer models of individual rail vehicles in our work because we have to evaluate how the vehicle responds to the input from the track. I'm not going to go into detail on each of the core research priorities listed on the slide because I'll talk about the group's particular research needs in much more detail later in the presentation. The rolling stock division is responsible for research involving rail vehicles, or in other words, everything from the top of the rail up. One of their core research priorities is better inspection of the rolling stock, which can involve machine vision systems using AI to identify vehicle issues. They also work to improve the design and materials used for the freight car and locomotive components. Their energy and environmental sustainability work typically involves locomotive fuel efficiency, use of alternative fuels for locomotives, and battery-powered locomotives. It can also involve electrification issues. Occupant protection has been in the news because of the recent Amtrak derailment in Montana. Some of the research that occurs in this area is how to better protect passengers during a derailment and how they can safely egress from a vehicle in the event of an emergency, whether that's a derailment, a fire, etc. It also looks at how to protect transportation employees in the locomotive in the event of a head-to-head train collision, and I'll give an example of that later. They're also heavily involved in work on tank car design and safety, and often collaborate with the Pipeline and Hazardous Materials Safety Administration, aka PHMSA, and that tank car work can include full-scale crash tests at our industry research facility. As you can see here, the focus of the Train Control and Communication Division is straightforward. Their core research priorities include monitoring the dependability and performance of the current generation of positive train control systems, which prevent train collisions, enforce track speed, and dispatching restrictions. They're also involved in the design of the next generation of positive train control, aka PTC 2.0. And this next generation of PTC could serve as the backbone for autonomous train operations. The intelligent transportation system shown here is the division's research in preventing crossing and trespasser fatalities using technology. And an example of this type of work is what is known as V2X systems, or vehicle to everything, as it's known, where a smart grade crossing can send a warning to approaching cars that a train is near the crossing, and vice versa, it can notify the train that a car is approaching the crossing. Obviously, AI and machine learning are important parts to all of their research. The focus of the Human Factors Division is also straightforward. In their core research priorities, train crew fatigue has been an ongoing issue in the industry, and they continue to research how sleep-wake cycles, health issues, etc. affect crew performance. As technology increases in the industry, the division is looking at how to design the best interfaces for people to interact with so that the vital information is clearly presented and can be acted upon. While both the train control and human factors divisions have responsibility for researching how to prevent grade crossing and trespasser fatalities, the human factors division approaches this from a psychological standpoint rather than a technology standpoint. Also, the division funds and oversees the Short Line Safety Institute, which helps smaller railroads develop safety programs and train their employees in railroad safety. Now that I've covered the structure of the RDNT office, I'd like to take a few minutes to talk about FRA's research facility, the Transportation Technology Center, or TTC for short, located just outside of Pueblo, Colorado. This site is truly a unique test facility. It's over 33,000 acres, has more than 50 miles of test track and 11 buildings. The picture on the right side of the slide is a site drawing of the entire facility. The yellow circled area that I'm highlighting with the laser pointer is shown on the bigger drawing right here is what we call the core area. The picture on the left-hand side of the slide is of that same core area. It's difficult to communicate the true scale of this facility in a presentation. So the building I'm now circling with my pointer on the left picture is the passenger service building, which is large enough to house an entire Acela train set. The next building that I'm going to circle, which is right here, is the Rail Dynamics Laboratory, which houses 2 full dynamic test fixtures that can each accommodate an 89-foot long test car and has room for quite a bit more equipment. You'll see a picture of those fixtures on the next slide. So I'd like to draw your attention to a couple of the tracks. The red track that I'm showing here with the laser pointer is the railroad test track, which is a 13.5-mile long high-speed loop for testing passenger equipment. It is equipped with catenary electrical power and has a maximum test speed of 165 miles per hour. The next generation Amtrak Acela consist completed its shakedown testing on the track earlier this year. I will also highlight the blue track here with the pointer, which is the high tonnage loop and is home to the famous Facility for Accelerated Service Testing. This track accumulates roughly 145 MGT of traffic each test season by running a loaded train around the loop as frequently as every 4 minutes during peak operations. That allows industry researchers to see how components or maintenance practices hold up to extreme traffic levels before they are ever placed in revenue service. TTC recently celebrated its 50th anniversary in service. The site was originally built in 1971 to conduct high-speed ground transportation research. And after 12 years of operation as a government facility, the American Association of Railroads, AAR, began operating the facility under a care, custody, and control agreement. That unique agreement allowed AAR to conduct both research for FRA and for the industry at the site. In 1998, AAR formed a for-profit subsidiary, the Transportation Technology Center Incorporated, or TTCI, which assumed the operating contract at the site and performs commercial testing in addition to FRA and industry research work. This past year, the contract to operate the facility was rebid and it was won by ENSCO, who will begin operating the facility in October 2022. TTCI will be moving to a new facility in the Pueblo area with both tracks and and test labs to continue their industry and commercial work. Due to the names, folks tend to associate the facility with TTCI, the AAR subsidiary. But just to be clear, TTC, the Transportation Technology Center, is a federally owned site and really falls under the jurisdiction of FRA. So the two photos at the bottom of the slide show the two test racks in the Rail Dynamics Laboratory building that I mentioned on the previous slide. As you can see, these are large dynamic test racks that can each hold an 89-foot long rail car. The simulator, which is on the right, focuses on loads applied into the car body of the rail vehicle. The vibration test unit, or VTU, on the left can apply independent loads to each wheel of the rail car. So it can test not only the car body, but also the freight car trucks and suspension. Interestingly, the VTU can also accommodate rubber-tired vehicles such as a bus. We anticipate in the future other DOT modes such as PHMSA, the Federal Transit Administration, the Federal Highway Administration, etc. will make more use of the site. And the site also serves as the primary training center for the FRA's Office of Safety Inspectors. Now I'd like to show you an example project to help tie everything together. As I mentioned earlier, the Rolling Stock Division does research on occupant protection in an accident. When two trains collide, one locomotive often overrides the other locomotive, resulting in injuries or even fatalities to the crew of the overridden locomotive. So the Rolling Stock Division conducted research to look at possible ways to prevent the locomotives from overriding. The video on the lower right shows a simulation of a device intended to solve this problem, while the video in the upper right shows an actual 19-mile-per-hour test conducted at TTC to confirm that the device would work. The picture on the lower left shows the assembly after that successful impact test. So how can you see the results of our work? Well, it's really very easy. All you do is go to the FRA e-library site at the address shown on the slide, and you can access all the reports we've published. As you can see, we've published just over 70 reports in each of the last 2 years. Research reports are generally short 4 to 5 page summaries of the research work, while technical reports generally range from 30 pages up to 300 pages and are full summaries of entire projects. So now we're to the important part of the presentation, which is how can you work with FRA? Well, the short answer to that is through our broad agency announcement program. So what's a broad agency announcement? Basically, it's a competitive open procurement process where we're soliciting research ideas that we believe can have an impact on both safety and efficiency of the rail industry. The awards are typically fixed price or cost type contracts. And one of the nice things about this program is that people who are submitting ideas can consult with the staff at FRA all the way up to the time a formal proposal is submitted. So it's a way to gain some feedback about whether an FRA is interested in an idea or if there's a specific direction that it needs to take. So how does that structure that program look? The announcement is made on sam.gov, and generally we have two different types of BAAs. One is a general BAA that is open to everyone, and then we have university BAAs which are only open to universities. It is a two-phase process. We first ask for a concept paper, which is limited to 5 pages. There's generally a 2-month open period, And those concepts need to relate to the specific research topics that we have asked for in the BAA announcement. Those are typically shown in Appendix C, which you can see an example of that on the right side of the screen. The concept papers will be evaluated by folks at FRA, and we will also call on the John A. Volpe Transportation Research Center folks for expertise in evaluating the concepts. Concepts that we believe have merit will then be invited to submit a more formal proposal that is limited to 20 pages, that has to be much more detailed. And again, those proposals will go through an evaluation process to see whether they are worthwhile to pursue. Concept papers and proposals that are not pursued will be provided with feedback on why we are not pursuing them. The award size in general runs from $150,000 to $1 million, although awards typically tend to fall on the lower end of that range. So now let's talk a little bit about research needs. I'll start by covering our high emphasis research topics. And these are topics that we receive direction from Congress to investigate. Trespasser and grade crossing fatalities is very, very high on Congress's list. It's high on FRA's list, state DOT agencies. There are multiple entities pursuing research in this area trying to resolve this problem. The general public does not realize the danger that they put themselves in sometimes, as you can see by the picture on the right. As I mentioned before, both our train control and our human factors divisions are looking at how do you address this problem from either a technology aspect or from a human/psychological aspect. Climate change and climate resilience are also very hot topics at the moment. Climate change primarily focused on research with alternative fuel locomotives, battery-powered locomotives, electrification for trains. The climate resilience is focused more on really the effect of climate events, extreme climate events on the track structure, whether that's higher temperatures, extreme rain events, extreme cold temperatures, etc. Automation is, of course, a hot topic across the transportation discipline. Just as automobiles and the trucking industry are pursuing driverless vehicles, the industry is looking towards autonomous trains. And I've actually seen here in the last week where there are 2 startups that are looking at autonomous rail vehicles, which will move under their own power from origin to destination without any crew or locomotive and can self-platoon, which is a very interesting concept. Within the automation, it's not just the train itself and reducing labor associated with train crews. That also goes into automation of the inspection process, both for track and rolling stock, and even applies to some of the signal inspections. Workforce development, even though it doesn't seem like a research topic, typically falls into our area. If you're not familiar with it, in the last decade, there has been a sea change in the employment demographics in the rail industry. Really, there was a large bubble of older employees who have since retired, and there's been a large influx of younger employees or inexperienced or lesser experienced employees. And so how does that knowledge transfer take place? how do we encourage people to go into railroading in the first place, pursue STEM educations, etc. Those are all items covered in workforce development. And now we come to the slide in the presentation that's nearest and dearest to my heart, because it's the slide where I get to talk about the track division's research needs. I often tell people that the objective of track research is straightforward. There's only so many ways that track can cause a derailment, and they're listed at the top of the slide. Unfortunately, trying to prevent these types of derailments is not simple or easy. There's really three challenges that we have to overcome. The first challenge is that we don't have a direct way to measure the underlying track conditions for many of these types of derailments. The second challenge is that the interactions between the factors that cause each type of derailment can be very complex and difficult to determine. The third challenge is that when we do identify a condition that could lead to derailment, it may not be easy to determine and fix the root cause. And as a result, the field forces may address a symptom, but not the root cause. And all three of these challenges need to be addressed for each of the derailment types listed above. So for the first challenge, we can consider three levels of inspection. Ideally, we would be able to directly measure the parameters that lead to a derailment. However, if we can't directly measure the parameters, the next best option would be to look for a proxy measurement that would allow us to infer something about the parameter. And if neither one of those options is available, then we would look for conditions we could identify that would indicate whether a section of track is significantly different than the rest of the line and deserves additional investigation. So let's consider a track buckle, for example. A track buckle occurs when the compressive stresses in the rail due to thermal expansion are so high that they overcome the lateral track strength of the track, resulting in an alignment deviation as shown in the picture on the right that wrecks a train. In the case of a buckle, we would like to be able to directly measure both sides of that equation, the forces in the rail and the lateral track strength. Right now, we can't directly measure either one. For a proxy measure of lateral track strength, we might consider measuring the lateral tie vibration as the measuring vehicle passes and infer the lateral track strength. The more vibration, the lower the track strength, since it would imply it's easier for the tie to move laterally. If we don't have a direct measure or a proxy measure, then we might look at a combination of conditions, such as ballast shoulder width, deficient ballast in the cribs, ballast fouling, etc., that might indicate a particular section of track is different than the rest of the line and requires further evaluation to determine if the lateral track strength is actually low or not. So addressing the second challenge will take good old-fashioned research to determine the interactions and their importance. In some cases, we may need machine learning or AI to figure out these relationships. When we talk about the third challenge, we have to bear in mind that the field forces are dealing with dirt, rock, sticks, spikes, and rail. That's all they have to work with. Identifying the root cause that needs to be fixed makes the repair process more efficient and ensures that the proper repair is made. And with that, I will move to questions. I know I've gone through a great deal of information in a very short time frame, and I thank you for your patience and am ready to answer whatever questions you have.